Hello everyone, I'm Sanjay Gupta from School of Planning and Architecture, Delhi. I'm going to make a presentation on user preference for electric vehicle adoption by small commercial vehicles for freight delivery in Delhi, India. And this paper is jointly co-authored with my PhD research scholar, Saloni Gupta. Urban freight is an extremely important component of cities' transport system. Goods transport account for 10 to 15% of vehicle equivalent kilometers traveled, 31% of energy use, and 31% of CO2 emissions, respectively, in urban areas, according to a UN Habitat 2013 report. Now, looking into the negative externalities of goods transport, such as pollutant emissions, there is an emerging need to decarbonize urban freight transport. In this respect, many projects around the world are aiming to decarbonize urban freight with a focus of use of EVs in the urban logistics spaces. The Government of India too has made an ambitious commitment to create demand for EVs through a scheme called Faster Adoption and Manufacturing of Electric Vehicles, FAME. And as a result, India's EVs market too is poised for a significant growth in the coming decade. As far as the freight transport is concerned, in the e-commerce sector, Flipkart in India has become the first e-commerce platform to commit a 100% adoption of EVs by 2030. Now, while electrification of freight use cases is gradually on the rise, particularly in the e-commerce operations, the small commercial vehicles electrification is still a challenge in Indian cities. Now, if we look up into the goods movement pattern in Indian cities, what we find is that the intensity of goods traffic particularly increases in metropolitan areas and actually tends to diminish as the cities become smaller in size. Moreover, the patterns of freight movement in cities reveal that about 40% of the traffic is normally through, which doesn't have any business with the city, while 60% roughly is the destined traffic. There are a wide variety of modes ranging from full trucks to light commercial vehicles and to even to non-motorized transport, reflecting a very diverse picture of different kinds of modes of transport used in goods delivery process. And obviously, electrifying urban freight is one of the very important strategies of decarbonizing urban freight in Indian context. Now, if you look up into the city profile of Delhi, we find that Delhi, a city of 20 million, has 10 million registered vehicles, of which nearly 70% of the vehicles are comprising of cars and two-wheelers. It's a very modern metropolis, and probably a city with the administrative seat of the country. There are an estimated 315,000 goods vehicles, out of which 63,000 are registered three-wheelers goods vehicles. In terms of e-commerce, nearly about 3 million orders per day are handled every day by the e-commerce players. If we look up into the freight movement characteristics in Delhi, what we find is that the goods vehicles, the regional good traffic has increased from nearly about 50,000 vehicles in 1993 to nearly 170,000 by 2020. And if you look up into the desired pattern, what we find is there is more intensity of incoming goods vehicles and relatively a lesser flow of outgoing vehicles. The through traffic almost has remained stable around 30% of the total regional movement happening at the cordon locations of Delhi. In terms of composition of goods vehicle, what we find is that the light commercial vehicles constitute 42%, while the trucks constitute another 32%, and the auto rickshaws comprise of 20%. In terms of payload, we find that the payload is increasing, which was about 4 tons in 1993, it's gone up to about 5.67 tons average payload. So which tends that there is a greater utilization of these freight delivery vehicles. If you look up into the impact on pollution, what we find that freight delivery vehicles are contributing to around 45% of the NOx, 41% of PM10, and a large proportion of PM2.5 vehicular pollution in Delhi. An estimated 0.7 million tons of carbon dioxide on account delivery vehicles took place in 2019. So in order to embark upon this study, we had these stakeholder interviews with various transport operators of these goods delivery vehicles, and largely the aim was to actually find out what are the barriers and what could be done in order to kind of ensure that they adopt the electric vehicles in freight delivery operations. So a sample of 200 small vehicle operators captured in South Delhi, comprising of fruits and vegetable delivery vehicles and groceries and parcels delivery of e-commerce were captured in South Delhi. A face-to-face interview was done using a pen and paper method, and their opinion was solicited. In terms of the composition of the sample, we found roughly about 57% were the operators who owned the vehicles, while 34% were drivers, where the vehicles were owned by the companies. In terms of salient characteristics of fruits and vegetables, what we found that in terms of there were two major types of goods delivery vehicles in this trade. There were the three-wheelers loader CNGs, and there were the vans CNGs. So what we found that the average daily vehicle utilization ranged anywhere between 40 to 58 kilometers per day, and these vehicles make around 2 to 2.7 trips in a day, transporting fair amount of quantities of freight, and they have about nearly about 10 to 10 and a half hours of operations every day. If you look up into the transport operation characteristics of groceries and parcels, what we find, there are four types of vehicles which are engaged. There are three-wheelers loader CNGs, there were two-wheeler petrol vehicles, there were EVs, three-wheeler EVs and two-wheeler EVs. Little bit of the analysis revealed that roughly about 48 to 68 kilometers the range is the daily average vehicle utilization. Obviously, the EVs are relatively doing lesser vehicle utilization compared to the CNG and the petrol vehicles, and the number of trips ranged anywhere around 8.5 to about 10.5. That is a kind of to about 14. Number of trips per day. Now, if you looked up into the commodity type, what we found that on average, grocery vehicle did about nearly 13 trips per day, whereas the parcels did around 10 trips per day. And if you looked up into their ownership pattern, obviously almost all of them were owned by the companies. They had a rough distribution areas of around 22 kilometers from the warehouse where these vehicles ply, and the drivers obviously are on a fixed month salary. Most of these vehicles, as far as the two-wheeler, three-wheeler EVs as well as the CNGs were about less than 5 years old, and it was only the two-wheeler petrol which was more than 5 years. Then further, we solicited the response from stakeholders about the knowledge in EVs, and we found that they were aware about EVs. Almost 90% said they were aware. They were also aware about the subsidies in general, that the subsidies do exist. However, when we tried to probe them further on the subsidies, they were not. Most of them were not very sure as to what were the details of it. So that is one issue that I think more greater sensitization of these people, operators, need to be done by the government to make sure that they understand the merits of the schemes. Obviously, in terms of the charging infrastructure, we found that most of them preferred the EV charging to be near to their origin destination, and very little actually preferred near public parking spaces, largely because they wanted to kind of not get stuck up in a queue system. Then we also solicited the weights for different kinds of barriers across stakeholder type using the classical analytical hierarchy process method, and we listed around 12 a dozen barriers which were there from the literature and from the other secondary studies. And what we found were the 3 or 4 key barriers which we found as far as the self or rented vehicles were concerned. Inadequate charging was a main issue, followed by what they reported was the charge, it gave them the less range in terms of kilometerage, and also high cost of vehicles, another factor. While the operators whose vehicles were owned, who had the company owned vehicles, for them the range was probably the most biggest issue. Cost obviously was not the factor for them since it was company's own, and followed by inadequate charging infrastructure. And they also kind of emphasized on the absence of battery swapping facilities. As far as the EV were concerned, again the range was probably the most critical factor for EV operators, followed by absence of battery swapping and inadequate charging. So in a way, there was a certain consistency of the opinion of across categories as far as the various barriers were. Then we also looked up into what are the barriers in terms of technical and economic barriers. So what obviously we found that in terms of technical barriers, the most important barrier was less electric range per charge. I think that is what the most critical point, followed by less battery life and fewer EV models, which was there. While in terms of economic barriers, high cost of vehicles, which was very important. They also had in terms of high battery replacement cost and obviously high price of charging. So these were some of the other kind of important factors which were there, and overall the consistency ratio was acceptable within the range. Further, we also solicited the weights for infrastructure barriers, and we found that inadequate charging infrastructure was probably very important, followed by fewer repair and maintenance facilities and absence of battery swapping facilities. So these were some of the key. Probably overall, if one were to look at it, the absence of battery swapping was probably rank 1 in terms of overall. Again, the consistency ratio was within the acceptable limit. So if you see the overall ranking of weights for barriers using EHV, what we found was less electric range per charge. I think that was critical. Inadequate charging was another thing, absence of battery swapping, and less battery life. I think these 4 kind of important barriers which probably most of them thought were very critical to be resolved. So in terms of solutions, certain solutions were put forward to them as to how would they assign weight to those. And again, obviously, the extensive EV charging infrastructure was solicited to be the most important solution for them. They also wanted more of awareness campaigns for logistic providers, because a lot of people were not really aware about it. And then obviously followed by financing from banks and more subsidies. So these were some of the kind of broad solutions which came out from this. So in a way, if one were to kind of sum it up in this thing, that what we have seen is that the Indian cities are witnessing intense freight movement, which is expected. India being one of the world's fastest growing economy, so it is bound to happen. Electrifying urban freight probably is one of the potential and emergent decarbonization strategies in Indian context. The studies reveal that the present study revealed that there are diverse category of small commercial vehicle operators involved in freight deliveries, but their opinions are fairly convergent, fairly consistent in terms of what are the barriers and what would they prefer. In light of the response which we got from various people, some of the strategies which could the government could take forward is how to strengthen the EV charging infrastructure for freight vehicles, and maybe possibly a dedicated freight charging infrastructure. Obviously, we need to conduct sensitization programs for small commercial vehicles, ensure technological improvement in enhancing electric charge range per charge, and possibilities of battery swapping facilities, and also ensuring that there are enough of finance and subsidies so that this whole program can move forward. So if I'm to sum it up, there is a need for what is called a desired incentive for commercial vehicles of various categories in the EV policies, which probably is not there, and along with supporting policies to enable a faster adoption of EVs and urban logistics. So thank you. Thank you.